Hi, everyone, and welcome. Thank you for joining us today for our Bridging the Distance webinar hosted by Ceragon Networks. My name is Dori Aran. I'm the Marketing Director for North America at Ceragon, and I'll be the moderator for today's event. We'd like to hear from you today, so ask questions and share comments. Please use the question and answer panel on your Zoom player. We have a very large audience today, so we will do our best to answer as many questions as possible. Our topic today, rural connectivity, is one that we often get questions about. So we've brought together a panel of experts to address it. We have with us Craig Breckner, CEO of Zurich Technology Solutions, Mike Womack, Director of Strategic Alliances at Ceragon Networks, and Brad Burwald, Senior Product Manager at Morningstar Corporation. This webinar is being recorded and the link will be sent to all the registrants. We have 3 quick polls that we will launch during today's event. We'd appreciate your participation. As I launch them, they will pop up right on your screen. We'll give you several seconds to answer them and then share the results. As a matter of fact, let me get the first one launched. Okay, here we go. So this one is about government funding. We'd like to know if you've engaged in any government funding to expand into any remote areas. That means using RDOF, RUS, BTOP, or any other government funds. I'll give you several seconds. Okay, 3 more seconds, last chance. Okay, and I'll end the poll now. So we have actually quite a large amount of yes, 24%, 49% no, and 27% it's just not relevant to them. So thanks for participating. To get things rolling today, I'll hand it off to our first presenter, Craig Breckner. Craig, take it away. You're on mute, Craig.
Okay, hi everyone, sorry about that. I was having some technical challenges here, but anyhow, thank you, Dory, for the introduction. My name is Craig Breckner. I'm the CEO of Zurich Technology Solutions, and we are a global systems integrator for complete on and off-grid wireless solutions. We're very excited to be here today to talk about this extremely important topic. Our services include engineering, R&D, design, procurement, warehousing, and logistics. So for the most part, we do it all when it comes to rural development of sites. And we have the ability to scale across the United States as well as the Caribbean and Latin America. And we're also a active member in TIP, which is a telecom infra project. Today, we're going to be introducing 2 of our key partners to talk about backhaul as well as solar and power systems. One of them is Ceragon, and the other one is Morningstar. Okay, the markets that we're going to be talking about today are primarily rural markets that have a market size between 1,000 to 4,000 people in those communities. So the solutions are tailored for that. The coverage type is either greenfield or expansion. The coverage radius is typically town center with maybe some coverage outside of the city center. The energy is off-grid, leveraging solar and backup. The service offering is 4G or 5G, and the backhaul that we're going to be presenting today is microwave, although it also can be done with satellite. And the ultimate goal of our deployments is obviously a 99.9% availability for the end-to-end site. Okay, so the current thinking today is that rural broadband or a bridge into digital divide is unthinkable or unreachable. And that's due to most of the technology today being designed for suburban areas, not rural low population areas. And we're here today to prove that this is no longer the case with the solutions that we're going to be presenting. So what are the rural broadband challenges that we've heard in the field talking with our customers? So clearly, number one is, do we have the resources to allocate to lower ARPU markets? Everyone on this call that's an MNO understands that in the rural markets, typically the ARPU is lower than in suburban markets. So that's a challenge. And how do you justify the business case for that? The second thing is, what will it cost to deploy? You know, typically the financials don't make sense to deploy in rural markets. When you factor in site acquisition, civil and electrical construction, tower leases, installation and support, it becomes very cost prohibitive, and it's been one of the main reasons why these sites have not been built. The third is, how do we address the fact that these markets are in hard to get to places? Typically, they could be 2 to 3 hours away from an MNO's closest technician. And how do you address that? How do you access these sites remotely? Because everyone knows that truck rolls are very expensive, and you want to be able to provide good service. Fourth, migration path. We've seen it with 3G technology that was built years ago with government funding. And today those 3G networks are not up to speed and are very challenging to provide broadband to the friends and families and employees and colleagues that are working from home and need high-speed connectivity wirelessly in some cases. And then lastly is, how do we handle the extreme pressure that's on all of us today, again, from friends and families and government agencies to bridge the distance? And how do we leverage some of the government funding that's currently available to all of us to build these networks? So these are the top 5 rural broadband challenges that we've seen and that we've heard and that we hope to address on this presentation. So how do we address these challenges, right? How do you bring it all together? So what Zurich does as a system integrator is, our role is to put together all the pieces and all the partners that actually make this happen. And we've done this successfully in Latin America as part of the TIP exchange program for a tier 1 operator. And we're doing it with other customers here domestically in the US. The way we do it is with consistent build with standardized suite of products. Typically, we identify a manufacturer for each element or each component of the network. So in this case, Ceragon would be great for microwave backhaul. Gilat is a partner of ours that we can use for the satellite if that's the route we go. Morningstar, who's also joining us today for solar power. They have an amazing solution that they're going to be sharing with you. Custom towers. Obviously, these towers are not your traditional towers, and they range from anywhere between 20 to 30 feet in height for rural markets. So typically, we find local manufacturers to make those for us. For RAN, we've worked with Bicels in the past, but also Nokia and Ericsson are quickly moving into this space, and they're offering very competitive pricing for rural markets. And then for the EPC, there are 2 approved vendors. One is Amerisoft and the other is T-Core, but there's also the possibility of using Facebook Connectivity's Magma, if you're not familiar with that, for a core as part of the network. And surprisingly, the total hardware cost for a solution like this can be less than $25,000 per site, which for those of you on this call that have been building networks for a long time, you know that that's obviously very, very economical and affordable to build a cell site. So with that, I'd like to turn it over to Mr. Mike Womack, who's going to walk you through the microwave backhaul. Take it away, Mike.
Thanks, Craig, and thanks for the introduction, and thank you everybody for joining us for this webinar today. I'd like to start off with a quick introduction to Ceragon.
Hey, Mike, before you keep going, do you mind if we just do the second poll first?
Go ahead.
Okay, let me just run that real quick. So this one, we'd like to get a gauging of people's thoughts about wireless and microwave versus fiber. So we'd like your thoughts on how does microwave stack up against fiber? And you could choose as many of these as you like. Is it more affordable and cost reduction? Is it faster time to market? More easily upgradable, better latency for long distance links? Do you think they're equivalent, or does fiber always beat out microwave? We'll give it several seconds. Okay, see it's slowing down, so I'll give it a couple seconds more. 3, 2, 1. All right, let me share the results here. We've got the biggest winner is that it's more affordable and a cost reduction, that's 68%. We've got 60% faster time to market, 38% think it's more easily upgradable, 18% think it's better latency for long distance, smaller 5% think that it's that they are equivalent, and 31% think that fiber always beats it out.
Okay, thanks for that, Dory. So let me share a quick introduction of Ceragon and really focusing on, from a foundational standpoint, giving everybody a perspective of the strategic value we bring as a solution provider. First off, as you look at this information, it just gives you a high-level perspective of Ceragon. A couple key points I want to bring up. First of all, we're a publicly traded company. We're a worldwide company. We have market leadership across the world with over 1 million systems deployed. We support a very diverse customer base with over 2,000 customers. Those 2,000 customers being in over 140 countries across the world. We leverage our internally developed chipset, which is a strategic advantage to us, and to really provide innovative technologies to some of the world's fastest growing networks, and benefiting businesses like yours, and really unlocking your business potential by providing very flexible wireless solutions. So where we see the market drivers from a broadband connectivity standpoint, there's 4 major points. One is, as most of you know, there's significant government funding, especially here in the US. There's definitely challenges as far as still rural America is still lagging as far as rural broadband deployment. There's some frequency band changes, and then there's also obviously a driver of consumer demand. So from going back to government funding, you'll see, you've all seen information as it relates to RDOF, rural utility service programs. There's a rip and replace of some of the Chinese manufacturers here in the US and some funding sources from that. NTIA from a broadband infrastructure grants. So there's significant billions of dollars of government funding that's helping provide broadband connectivity across rural regions. From a US perspective, you know, I mentioned rural America is still lagging. At the end of 2019, there was 17% in rural areas still needing coverage, and then in tribal lands, you know, still at 21% coverage with the 25/3 megabyte broadband initiative. From a frequency band perspective, there's new mechanisms for connectivity. Plenty of new cost-effective options to provide services for your customers. Everything from CBRS to C-band to a number of different frequencies that have opened up, and technologies that have come out to support that. And last but not least is the demand that consumers are bringing. We saw a paradigm shift related to COVID, and you know, where people were working from home, and you know, sometime as we're coming out of COVID, you know, that we're still seeing many offices closing permanently, keeping staff remotely, driving capacity intensive applications, you know, needing time to market solutions, and looking at wireless versus fiber to meet those timeline demands, and really seeing that digital transformation from a consumer demand standpoint. So some of the benefits that we see, just to outline those, there's basically three main benefits that rural broadband provides and can provide to rural communities. Number one is enabling employment. Number two, we see economic development. And then number three really hits home, and that's quality of life. You know, where we live, where we work, where we play, increasing the quality of life. A lot of that has to do with, you know, by getting rural broadband connectivity to these communities allows for expanded applications. Everything from, you know, city buildings having predictive maintenance to smart agriculture, to smart water systems, to telemedicine. So a number of applications, remote education. We've seen that a lot during COVID. Those types of applications really expanding and allowing rural communities to benefit from broadband. So the poll that we had earlier, fiber versus microwave, we don't see it really being fiber versus microwave. We see it being as complementary services to each other. Both offer definite capabilities and pros to what they have to offer in certain situations. Fiber isn't available everywhere, and the way we see it, microwave fills those gaps. So we look at it as more of a hybrid approach. When some of the things to consider for considerations for wireless are basically, you know, fourfold. It can be combined with existing fiber networks to cover more area at a lower cost. So when in most cases, when you roll out fiber, you have to cover a whole market. With wireless, you can pick and choose which areas to cover. So that's point number one. Point number two is, if you have an outlying area that you want to pull into existing network, but that geographic gap is pretty large, you can use microwave to pull it into the existing network. And then the last 2 points is really about cost and timing, being able to go to market at a fraction of the cost and time versus, you know, the fiber build being, you know, wireless being 1/10 of the cost of fiber, and you can quickly roll out wireless to meet your, you know, service enablement timeframes and time to market. So one of the big questions that comes up when you talk about wireless and microwave is, you know, being able to cover the distance and be able to cover the distance with capacity. So one of the things as we talk about with distances, microwave offers lots of different options to drive multi-gigabyte capacity, both over a short haul and long haul distance spectrum. So enabled through different frequency bands, you know, everything from 6 gigahertz all the way to you know, shorter distances with millimeter wave. So as you look at long haul, you know, 6 gigahertz is typically what you would use there, and all the way down to 23 gigahertz and millimeter wave technology for some of the shorter distance. But the key is being able to drive multi-gigabyte capacity over whatever distance that you need, whether it be long haul or short haul. So the other thing to think about is different deployment scenarios. In whatever region you are within the you know, the U.S. Or internationally, there's some considerations to think about and what deployment scenarios you need to look at. The good news is that with wireless, you have the flexibility to address specific regions and those specific regions' climates, to address, resource constraints, to address overall costs. And you can do that through, in wireless and microwave, through 3 different options, whether it be an all outdoor where the radio's up on the pole right behind the antenna, to a split mount where you have the radio frequency unit behind the antenna, and then you have the indoor unit in the cabinet or in a building, or if you prefer all indoor and have that with your other equipment like we show pictured here on the bottom right hand side. So a lot of flexibility that it has to offer. And just to kind of insert Ceragon in here, as you look at the different options, whether you're looking at short haul, long haul, ultra high capacity, different deployment scenarios, 100 megabits capacity all the way up to 20 gigabits capacity, Ceragon provides a single portfolio and a single platform to serve all your backhaul needs. So going with the theme as far as addressing rural broadband ROI challenges, and the comment that Craig said earlier about technology does exist to bring connectivity to remote areas and meet those ROI challenges, some of the things that Ceragon does to provide efficiencies and overcome some of those ROI challenges is building the products to be more efficient and focusing on how can we reduce CapEx and OpEx and provide ROI savings to our end user customers. So some of the themes here that I'll go through some examples on is, increasing the capacity but not increasing the power consumption, more effectively utilizing spectrum, allowing customers to increase their end user services at the same time as we're, reducing consumption, increasing capacity, and all that. So here's some examples as I go through this. So with the theme of cutting CapEx, Ceragon uses a multi-core technology with parallel radio processing that focuses on increasing higher capacity, longer distances, better availability, but at the same time, inherently cutting the costs and the power consumption in our products, and therefore reducing the overall operations when those particular solutions are deployed. Point number 2, power efficiency. We have the capability to with our advanced technology, being able to allow companies to dynamically use the power in a most effective way through an advanced technology called green mode, which allows a company to reduce the transmit power consumption by automatically reducing the transmit power, but also quickly increasing the transmit power in case the fading is less than 0.1, fading of 0.1 seconds. So no real traffic impact. So green mode technology, or the green mode capabilities, really helps for situations where you are looking to reduce the power consumption at the particular deployments out there in rural America. Again, power efficiency. So with split mount and all indoor scenarios, how do you reduce the overall heat management and decrease your overall OpEx? So we do that by, less equipment, therefore less power, really to minimize the heat dissipation, effectively requiring less air condition. And this is typically seen in deployments where they're split mount and all indoor, where we focus on reducing those particular costs and providing more efficiency power use. CapEx savings. So with the technology that we have, we're focused on how can we lower the CapEx. One of those things is with the modernization and advanced technology, we're able to reduce the need for antenna size, the bigger antenna size, and reducing that to smaller antenna sizes. Therefore, reducing costs, therefore reducing tower load and any tower constraints that are out there, and really simplifying the installation and reducing the cost of installation, and then the overall savings as far as lease costs on the tower as well. And then last but not least, a smaller form factor that's more environmentally friendly. End game being the fact that you get ROI savings, savings anywhere from $900 to $1,600 per link savings. If you have an existing network, we have a solution for that as well to cut CapEx, eliminating antenna swap. Wouldn't it be nice to keep the antenna up there, keep the investment and have investment protection up there? We can do that simply by adding the radio, adding a Ceragon adapter, and utilizing the existing antenna. Therefore, not only reducing the cost of the antenna, but also reducing the time to installation, the cost of installation, and not having to take the antenna down and the costs associated with that from a services standpoint. So really eliminating antenna swaps. Talked earlier about spectrum efficiency, and in this particular case, the theme is cutting OpEx. So from a spectrum efficiency standpoint, we instead of being stuck at lower modulations, we're able to utilize spectrum in a more efficient ways for our customers, therefore cutting overall OpEx expense. And then normally if you have to increase capacity, you'll have to do a truck roll and have a site visit, do it during a maintenance window, have somebody climb the tower. So there's a large expense to upgrade. From a Ceragon perspective, we have the ability to do a one-step remote upgrade. So somebody remotely being able to upgrade from a 1+0 to a 2+0 and effectively double the capacity. So once again, minimizing site visits and reducing the overall operation expense. So the last few slides I have, and then I'll hand it off to Brad with Morningstar, is focused on really the case, three different case studies. Two of them are here in the US and one's international. The first case study that we did that kind of pulls all this together is with a large tier 2 rural service provider here in the US. The challenge at the time was to get high-speed broadband to rural markets quickly and to blanket rural America with broadband. The solution that we brought was not only the microwave products and the wireless backhaul, but helping them design, analyze their site acquisitions, permitting, and then really providing the high capacity gigabyte speed solutions to support their deployments. The result was they were able to, over the course of time, over a couple of years, they were able to cover over 18 states where they were able to provide high-speed broadband, internet, phone services, etc., and ultimately deployed over 500 of our Ceragon radios and over 200 links. The next case study that I wanted to bring to your attention is right here in the heartland, right here in Nebraska, right in the middle of the US, and that was for Nebraska Regional Interoperability Network. So the challenge there was, how do I provide capacity over long distances? How do I network and interconnect over 103 public safety access points and other E911 centers across the state of Nebraska, as well as provide a redundant network. So Ceragon, once again, provided the design analysis, site acquisition, permitting, and high-speed solutions. So the result was that now they have a statewide microwave network connecting E911 centers across the state. It could be any other service, but in this particular case, it was connecting E911 centers. And now INREN is able to share large amounts of data and communicate with each other over long distances in a way that is secure and reliable through having 200 microwave links from Ceragon. And the last case study, and I'll hand it over to Brad, is with Orange in Niger, which is a country in West Africa. The challenge there was only 25% of the population had internet. The nationwide backbone required more capacity, and they had to overcome some of the rent and availability challenges. The solution that was deployed was in 8 gigahertz frequency. Capacity was anywhere from 1.8 to 4 gig. The max links distance was 26 miles, and there was over 96 links deployed. So the result was a high capacity backbone with a high power multi-core solution. And they were able to overly reduce their TCO and provide high capacity links and wideband channels, use smaller antennas, and really leverage Ceragon's services to allow them to rapidly deploy. So that was the last case study, and I'll hand this off to Brad to take you through some information on Morningstar.
Appreciate that very much, Mike. Thanks for covering those case studies. And, that's a part of our presentation as well. We want to give examples of, how the accessibility is there, as Craig had said in the beginning, being able to reach beyond these, dense areas or even suburban into rural areas, where there's more subscribers, but with less density, and, how we can enable that with the connectivity you talked about and the power systems that I'm going to cover now as well. So first, before we get started, let's see here. If I can go ahead and bring up the last poll. It's have you deployed wireless with solar as primary or backup power source before? So I'm going to go ahead and launch that poll question. So if everyone's got that up in front of you, a lot of answers coming in very quickly. So I'll leave that up for a few moments and then cover the results. Because personally, this is something I'd like to know. And while we're waiting for the results, you'll see that there's going to be, it's a great opportunity for a lot of this coverage, with wireless backhaul, both microwave and satellite, as was discussed, and also with solar enabling that. We've seen a lot of solar hybrid applications previously, of course, with gensets, but we're really seeing the era in the last few years of, pure solar being extremely reliable. So it'll be good to talk about that. Okay, so I'll be ending the polling, and this is a very interesting result. Despite all the attendees we've got a 50-50 split between the yes and the no of have you used solar as a primary backup. So we have both a lot of experience being reflected here with people that have utilized solar, and then the 50% that haven't. We're hoping we can influence you greatly today. Okay, so with that poll being finished, I'll go ahead and get started on my portion. So we'll be covering the renewable energy side of things, the critical power that's going to be powering this technology, the RANs and the backhaul connectivity. So, one of the greatest challenges of this connectivity is, of course, the reliability. That 99.9% uptime is really important because, you've got subscribers in this region. They're counting on the service, not just the entertainment aspect, commerce, education, and critical infrastructure. I thought the E911 case study that Mike talked about was very interesting because you can see how important these are. So what I'll be talking about a little bit is Morningstar, a little bit about the power system design process and how an integrated power system put together, turnkey, by Zurich, can enable all these pieces to come together. The access radios, the core, the backhaul, and the management and reliability of the power and the storage system, the battery system as well. Okay, so first a little bit about Morningstar, and first let me reintroduce myself again. Senior Product Manager at Morningstar. My name is Brad Burwald, and I've been with the company just under 20 years now in our 28-year history, and have covered a lot of telecom over the years in a variety of locations. Although, many years back at very different price points and very different efficiencies when solar, still had a lot of efficiency gains to be making on the technology side. With Morningstar, our products are focused primarily on the charge controllers, the battery charging devices. So this would be really our flagship products, the TriStar and ProStar series, which you'll see in their latest generations, along with a host of other products that make up our portfolio. And we cover a lot of areas, including some residential and rural electrification, but industrial solar, specifically that around utility infrastructure, telecommunications, security, and commercial applications is really our strongest area. And a lot of the projects we've covered, of which there are many, documented on our website, one of the more notable ones, just to get some of the breadth of what we've done with electrifying both telecom as well as the populace, was a large off-grid project that we worked on in Peru, which actually electrified 200,000 homes with individual power systems, 3,000 community centers. So working at scale in these high reliability instances is something we're very familiar with. So we cover those industry areas. And on the next slide, our core competency, as I said, is the charge controller, and that's really around a product line that makes up both MPPT as well as PWM products. The maximum power point tracking products are really our focus because they best utilize the module voltages that are available today. With modules being in the 400 watt per module range, being able to stack and parallel those modules in an effective way really benefits from the MPPT technology. And then also gets a lot of harvest for maximum delivery into the batteries and really deals with shade and other issues that might impact the site. You'll also see that a lot of the certifications that are actually covered by our products are very focused on the telecom market. Of course, our FCC Class B, our quality certifications, and also those covered by both IEC as well as ETL and UL. Because safety, especially with higher voltage, is critical, but also covers a lot of industry best practices for charge controller design as well with our products. So again, being part of the telecom industry and providing power, we are also a participant in the Telecom Infra project. Craig had talked about that earlier, and this is something that we're proud of being a part of, along with the other members in the TIP program, as being a power system solutions provider for the total site solution, which is really, it's a template for these exact systems that we're talking about. Configured systems, integrated. Zurich has done these complete system builds that encompass all of the components in a turnkey system, and really it sets a standard for what a low-cost, rural optimized system can look like, both from the wireless RAN access as well as the backhaul connectivity, and also the power system, which includes power system management as well. There's a large data component to all three of those devices, and monitoring that in a structured way to benefit from that size system is really important. So again, we're proud to be part of that TIP project as well. So I'm going to be covering some of case studies as well, because it really gives a good understanding of what we're going after here, both for international business as well as in North America, where there's great opportunities on these rural access and rural telecom deployments. So first was Africa Mobile Networks, a company providing access for Africa. And of course, the challenges here were, subscriber demand wasn't, clearly understood. There was a little bit of risk there, but they wanted to provide coverage on the fringe of the existing network. There was high OpEx for, the network operators themselves. No terrestrial transport, so wireless, satellite, and microwave were the only options. And also, even in a hybrid solar system, diesel generators not really practical. They were looking for a pure solar solution. So in this case, these small cell power systems were able to be deployed. There was a single, RAN, really low CapEx, very small footprint, as you can see, did not require a lot of infrastructure or construction. These sites were even designed such that they could be moved if the climate or the coverage for the subscribers was not what was desired. It can actually be relocated. And this is 100% solar application powered by the Morningstar products. And another example of a rural case study with Vanu, Rwanda, similar challenges. Rural coverage needed to be handled by systems that were very light, and the conventions were not really going to work in these applications. And there was some grid, but it was considered bad grid or unreliable, so it couldn't be counted on. So the solution was an Open RAN compliant GSM network. This was a complete turnkey system as well, very cost effective. And in this case, whereas the previous system used satellite backhaul, this utilized microwave. So again, the two wireless technologies there really providing the backbone connectivity for the site. So those two case studies give you a little bit of an example of, the types of systems that we're looking at to see, deployed. So here's what a power system might look like. And again, Zurich, can put these systems together and provide that total integration, including, data and the right sizing and configuration for the system need of the customer. So in this quick example, you have both data connectivity. You've got a primary connection for your high priority load, which would be the backhaul, so that you can maintain communications with the site. And then you've got the secondary connection for the actual RAN itself, which provides the service. And then with that, there's some monitoring in place. This happened to be a PoE powered system. And then there, can be various site accessories as well for security or, site monitoring and control. So all those things can be put together into a single package, and you'll see the TriStar PPT as part of the scalable portion of the power there. And then if you look at, what a larger application, might look like turnkey after integrated from Zurich, you can see that the TriStar PPTs can be used in parallel, in this case, 6 of them for up to 18 kilowatts of solar power, as well as the options for hybrid grid operation or integration of a genset. But we're really going after pure solar in these cases because the reliability is there and the system sizing, meets those needs. So you can see that what is typically looked for in a turnkey system like this are these applications. And you'll notice the bottom bullet there, multi-tenant metering and control is also a very important one. So what I'll touch on briefly here is just an overview of what you would see in a typical, how this site process is done. Not in a training effort, but just to give you a quick overview of, what goes into these system designs. And when Zurich looks at all these factors and puts that total system together, they're going through this same process on looking at the load, the available solar resource at that geographic location, the configuration of the array, and then proper sizing of the battery storage system. Okay, so first, a load size, a really good understanding of the load configuration is required, not only the backhaul and the RAN, but also inefficiencies such as losses in the system. And when you get that all calculated, this is a 24/7 site. Many sites are looking at, intermittent windows of scheduling to optimize power usage. In this case, it's on all the time. And then we look at various efficiencies and you come up with a view of the load profile. A next step here would be looking at the solar levels available for charging. Not all sites are as effective, but I do know that, it does not have to be a sunny location. Even northern Canada, we've had great success with reliable telecom, system power. In this case, a typical site would be viewed based on its coordinates, and you would take the worst case scenario. In this case, in Brazil, it was actually in May, and you size based on that, so that if that's your worst case scenario, then things will only improve and you have, even more upside when you have more solar resource available during the summer months. Okay, and that's how we plan for the reliability. The third step would be really to look at, now that you have the available power defined that you have to provide for the loads, what would a PV module array look like that's going to provide adequate power based on those sizing conditions. So we look at configurations, the TriStar PPT product being the most flexible in terms of input range, and come up with a proper sizing based on the solar modules that were chosen for the system. And then the last step is once you've got load and PV, then you have to look at your storage applications. And you can't just use a bigger bank for more capacity. It has to be balanced with the PV array. It's like having a fuel tank that's extra large. If you don't have the capacity to refill it properly, it doesn't really get you much benefit. So it has to be done in conjunction with the rest of the system sizing. So we'll look at that depth of discharge, the battery lifetime, and plan for those metrics. And then you also, a common question we get now is the transition to the lithium chemistry from lead acid. We'll typically see, systems, and I know Zurich can provide both those options for deployments depending on, the site's needs and cost targets, but both lithium and lead acid efficiencies can be taken into account in the system as well. So a few other things to think about when you're looking at system design is, of course, mitigating or ideally avoiding shade entirely, but we know sometimes it's just an issue depending on the site location. The system in the photo at the bottom there, you can see arrays on the top of the pole, so there's no self-shading, and that looks like an ideal skyline in terms of no trees. So that's an important part. Also looking at an iterative process with design, when you collect a certain amount of data from the sites, you can do all the predictive analysis you want with a system sizing tool, but it really takes site verification to really show what the actual performance is going to be in the end. So we, talk about data quite a bit in our system designs and with controllers to make sure that that data can be leveraged. And then lastly, on the side, one factor that has to be accepted, you want to have that 99.9% uptime, but you may have to introduce load control, which is protecting the battery from an extreme deep discharge. But that can be managed remotely and meet the expectations of the customer. And with that load monitoring, you can verify after the fact, having a year or two installation, you can re-verify with that site, is the load consuming what we expected when we did the load profiling? Are we seeing, dangerously low battery voltages where there's risk of an outage? Or that's something we call, what is the percentage risk or loss of load probability? That's really the key metric that we're trying to go after, and in this case, prevent. Is the system able to recover? Is the battery getting back to a healthy 100% state of charge at fairly regular intervals? And then lastly, if you're getting into the later stages of deployment, you'll see that as loads increase and battery runtime reduces, you might see that you're having a period where you reach the end of the battery life. And there's some telltale signs for that will be revealing when you look at the data. Okay, so all that information really is part of the system sizing opportunity. And with that, I conclude my presentation, and I will hand this back to Craig. Thank you very much.
Thank you, Brad. Thank you, Mike. And thank you to all of you who have attended the seminar today. I believe we've demonstrated on the webinar that bridging the distance is a reality today. Clearly, there are lots of business cases out there that will support that, and there are lots of examples that we've provided where we're actually doing this. As a systems integrator, Zurich can pull this all together for you as an MNO. There are a lot of components that need to be put together, as I shared on the previous slides, but through our relationships at Morningstar and Ceragon and others, we'd be happy to partner with any MNO that would like to do a market trial or field trial, or maybe even just build 1 or 2 sites just to see how it goes. According to the Federal Communications Commission, there's still nearly 30 million Americans without access to high-speed broadband service. So this is something that I think is obviously very important, and as leaders in the industry that we are, I feel like we all have a responsibility to make sure that all people have access to education, healthcare, entertainment, and more. So we're committed to this process as a company, Zurich is, and I know Ceragon and Morningstar, and I know the attendees on this call are as well, or you wouldn't have joined us. So collectively, I believe we can make it happen. I think it's it's a right, and we look forward to working with all of you. So here's our contact information, and this slide deck will be shared with all of the participants. And I believe, Dory, we've got a little bit of time to do some Q&A. Would you mind taking over, and maybe we can run through some of the Q&A? Are you there, Dory? Okay. Mike, would you mind taking a look at the Q&A? I know that a lot of it was related to Ceragon, and there were a few that were related to Brad's presentation as well. But we've got 8 minutes, and I'd like to address some of them.
Yeah. So the first question was, what are the key OpEx for low-cost site mentioned? And I don't know.
Okay. I could take a quick shot at that. I mean, the OpEx to build an off-grid rural site basically consists of some light construction, which is usually a cement pad, right? There's a battery cabinet that's required to be able to store the digital components. There is the product from Morningstar, which are the controllers. There's also the solar panels that are needed. Very simply, the monopole tower or a lattice type tower to be installed. Then you need either a satellite dish from Gilat or a microwave dishes and antennas from Ceragon. You need your cabling. You need a few battery strings to be able to provide power when solar is not an option. And then you need a RAN, right? You need a radio to hang up on the tower. So whether it's buy cells or something else. So for the most part, those are the expenses, and then you've got your consumables and installation related materials. So I hope that answered the question.
Second question is, what kind of end user costs, or what kind of, number one, end user costs, and number two, what kind of speeds to end users?
I can take a shot at that, Mike. I think we mentioned earlier that the sites that we built have been 4G, 5G compatible or capable. So, you're looking at 4G, 5G speeds with the sites that we built in rural markets.
Next question is, how does Ceragon technology deal with frequency interfaces compared to other products? I'll take a shot at that, and we can follow up later as well. So from a frequency interference standpoint, everything's engineered to reduce and eliminate interference. So up front, the products are engineered from point A to point B with the identity that not only do you have a line of sight, but you also, especially here in the US, you have you license it with the FCC, which under those licenses you have it approved to being with that particular channel has no interference type of thing, etc. So it's all done up front from an engineering standpoint. The Ceragon technology affected by weather during transmission? Same type of answer, and we can expand later if we need to. But from a Ceragon perspective, everything up front is engineered with the reliability numbers that the customer is using within the region that they're looking to deploy it, and in the climates and rain regions, etc., that they're looking to deploy. So therefore, reducing any weather-related effects with the transmission and looking to eliminate that. There was another one. For Brad, what type of telematics do you on the solar panels and the battery system to predetermine any impending failures?
Okay, yeah, so what we look for is, we're collecting data on not only PV production and load consumption, but also the battery cycling. We look at the voltage, we look at the amount of current, the net current going in and out. And over time, there's not only can you see, trends that will show, a reduction in battery health, but you'll also start to see that the battery is not as resilient. It's not coming back to a full state of charge. and it potentially could be that it's dipping in voltage and state of charge more rapidly than it was in previous time periods, and those can be indicators that the battery is starting to fail. And also, if you start to see extended battery charge times where it's taking longer to reach a full state of charge, then you'll typically see that you might need to look at a battery replacement. And again, that depends on the type of battery. Lead acid being a little more prone to, stress and early failure, especially in high temperatures, although still very cost effective. And then of course, lithium has a longer life, but a higher upfront cost.
Next question for you, Brad. How does one account for short winter days as well as snow and ice covering solar panels, which at the same time are inaccessible due to closed roads?
Okay, that's a good question. In the cases of winter, yeah, if you have extreme snow and ice, that could be some of the downtime that you've got to take into account in your days of autonomy. A lot of the markets we typically are expanding in these areas are not extreme winter sites. But as I said in my presentation, in Northern Canada, we've got lots of successful sites. You'll be surprised that modules, even in cold temperatures, do heat quite a bit when they're in operation. So they do a good job of actually melting a lot of the ice. Not in all cases, but they're usually more resilient than you'd expect. They definitely don't go down for the winter, or else they wouldn't be reliable. And in terms of inaccessibility for closed roads, we work with a lot of the rural WISP providers, and they've got some ATVs, so that might help.
So I'm not sure of this question. Maybe you can make sense of which of the address of internet which can be found the amount of solar radiation, PV watts, question mark. I'm not sure if that's enough detail.
In some of the presentation slides we covered, there was some site sizing tools, one that provided solar insolation levels for geographic areas that you can look it up. That was in the video. However, I will check with Dory. I think we can make those links available after the presentation, maybe with a follow-up. So we'll take a look at that.
Another question was, which is the best RF on microwaves for the backbone links? I'm assuming you're talking about the frequencies. So that would, for backbone links, long distances, that would be 6 gigahertz, most likely, depending on the distance. Now, let me see if there was any other questions. One other question, what are some of the networking monitoring tools going to be used by Ceragon products, and is there specific free tools for them? Ceragon has a solution called NetMaster, which is a network monitoring and management tool. Some of that information can be looked up on our website, and we can provide more details as needed.
I'll just add to that on the power side, since we work a lot in telecom, NMSs, they're primarily targeted towards bandwidth and monitoring of the wireless equipment, but Morningstar products do support SNMP so that they can actually have their data collected by those same network management tools. So that way you can use a single platform for monitoring both power and data.
And we're at the top of the hour, and that, I think we've covered most, if not all, the questions. If there's follow-up questions, let us know. And there is a survey that will load right after the webinar that we would appreciate if you could respond to. And thank you, everybody, for your time.
Thank you.
Okay. Thanks, everyone.